All right, welcome back to Chapter 4. We're going to stay in Section 1 today. So this will be 4.1, Day 2 in your notes. You can see that at the top right corner, or top left corner. What we're going to do today, instead of just using our matrix operations to simplify, either adding, subtracting, or multiplying by a scalar with our matrices, what we're going to do is we're going to use these to solve matrix equations. We'll solve matrix equations a little differently later in this chapter, but for now, this is kind of the setup that we're going to look at. So with these, you're just going to follow your order of operations like you normally do. Since I have my two matrices inside the parentheses on the left-hand side, says I need to add those before I multiply by that scalar of 2. So when I add these two matrices, I add my 3x and my 4 to get 3x plus 4. I add my 8 and my negative 2 to get 6. I get my 1 and my negative 1, add those together to get 0. And then I have a 5 plus a negative y, which we can just write as 5 minus y or 5 plus negative y, whatever you feel most comfortable with. We still have that scalar of 2 out front, and we know that that has to equal the matrix of 26, 12, 0, and 8. Next, we need to multiply by that scalar, so everything gets multiplied by 2. When I look at this 3x minus 4, you almost have to do a distributive property there, so everything there gets multiplied by 2, so you end up with 6x plus 8, and then I move down to my 6 to get a 12. 0 times 2 leaves me with 0, and again I've got to distribute this 2 to the 5 and the y in the bottom right hand corner there, so we're going to get 10 minus 2y. And that is going to still stay the same side, same right side, so 26, 12, 0, and 8. All right, now, the whole thing about these is, if you remember from yesterday, or the last video, we talked about how if we have equal matrices, they have the same corresponding values. So, as you can see, our top right is 0 on the left-hand side, our top right entry is 0 on the left-hand side. So, the whole key to this problem is the fact that these are equal. So, we can take a look and we see that 6x plus 8, well, that has to correspond to that 26. They're both in the top left corner of our matrices. So, if they are going to be equal, those two entries have to be equal. So I can set up 6x plus 8 is equal to 26. And I need to do the same thing for my y's. That's on the bottom right, 10 minus 2y. And the bottom right on the right-hand side is going to be 8. So I get 10 minus 2y is equal to 8. And then I just solve. These are just two equations that I can solve like we've been doing probably since you were in middle school, maybe Algebra 1. So we're going to subtract 8 from both sides in the green. I get that 6x is equal to 18. Divide both sides by 6. I get that x is equal to 3. Then if I hop over to my red equation, I'm going to subtract 10 from both sides. I get negative 2y is equal to negative 2. Divide both sides by negative 2. I get that y is equal to 1. With these, we're not talking about ordered pairs yet, so I'm okay right now. If you guys just leave these as x equals 3, y equals 1, those are perfectly fine answers for me right now. We'll talk about how we deal with ordered pairs and matrices later, but for right now, you're just solving equations. Just tell me what x and y are. Couple properties of these matrix operations. We've talked about all of these properties as they pertain to real numbers, but now we're going to talk about them dealing with matrix operations. So your associative property of addition, it says if you're adding three numbers and you put parentheses around two of them, it doesn't matter where you put those parentheses, whether you put them around A plus B or B plus C, they're going to be the same. You're going to get the same answer. Those are going to be equal to each other. Commutative property of addition, if you have matrix A plus matrix B, that's going to equal matrix B plus matrix A. Just like with real numbers, you can think of it 3 plus 4 is 4 plus 3. So that is your commutative property of addition. And then as long as we are multiplying by a scalar, so little lowercase c down at the bottom here, we can still use our distributive property as it pertains to scalars. So looking back at this problem here, I could have distributed that scalar of 2 to both of my matrices in the parentheses first and then added. I just think it's a little easier to add before you multiply by that scalar. So that's why I chose to do that the way that I did. So, and it works whether you are adding inside your parentheses or subtracting those matrices. It just depends on what you have. It works the same way. The nice thing about matrices is they can actually be used to organize information, make it a little easier for us to read and handle that information that we have. So, problem that we have, we give you healthcare plan information. For individuals, we've got comprehensive, HMO standard, and HMO plus, costing $694.32, $451.80, and $489.48 respectively. In case you guys haven't seen this word respectively before, it means in that order. So comprehensive is going to be the first one listed. That $694.32 is the first number listed, so it means that those two go together. HMO standard is the second one listed. The $451.80 is the second number listed, so those are going to go together. So respectively just means in that order, so they're going to follow the same order. So we've got two separate types of healthcare plans. We've got one for individuals and we've got one for families. So to organize these, it's really not too bad. All we're going to do is we're going to split it up. I'm going to put, just like our tables from the last chapter, I'm going to put the two big categories up top, and I'm going to put the subcategories within there. So the two main things that we're comparing, I've highlighted in green there, individuals and families. So I'm just going to abbreviate individual to IND, and family is going to go up top. Now, within that, we've got three different types of healthcare plans that they can choose from. We've got the comprehensive, we have the standard, and we've got the plus. Really, when you're organizing these, I'm going to be honest with you, it doesn't matter whether the individual and family becomes your rows and your comprehensive, standard, and plus becomes your columns. This is just the way that I set it up, so you could flip my rows and columns and it would work the same way. Then all it is we are just filling in what we know about these. So the individual comprehensive is $694.32. Get that right from the problem there. Standard is $451.80, and the plus is going to be $489.48. The family comprehensive, $1725.56, guess I can't read today. The standard is going to be $1187.76, and the plus is going to be 12, 48, 12. All we do from there, put our brackets in. We've got a nice matrix right there. And then we're going to label this one, we're going to call this one this year. Since that's the information that we pulled from each category. And just for future reference, I'm going to call this matrix A. It'll help us with the next problem just by being able to refer to this year as A, and I will set one up for next year. I'm going to call that matrix B. Being able to refer to those as A and B is just going to save us a little bit of writing in the next problem. So we're going to use these same ones. Again, we've got the same kind of categories. We've got individuals and families. So we set up our matrix the same way. Comprehensive, standard, and our plus. And again, we just go back up into the problem, and we're going to see how much each of these costs. So an individual comprehensive next year is going to be $683.91. Standard is going to be $463.10. And a plus is going to be $499.27. Then, for a family, the standard is going to be $1699.48. That's comprehensive. The standard is going to be $1217.45, and the plus is going to be $1273.08. Again, put our brackets around our matrix. That's how we signify that we're working with a matrix. And I've got my two matrices right here, giving the values for this year and next year for the three different types of healthcare plans and the individual and family. You know, this is actually something that you guys will probably work with someday in the real world. You'll have to look at different types of healthcare plans, and at least when I looked at mine for the school that I get through the school, they ended up giving it to me in a matrix, and it worked really well for me. So then moving on, so we've got the same healthcare plans that we were working with in the last problem. The employees receive monthly paychecks, and then the payments are deducted. That's if you get healthcare through your employer from your job, it's usually how they do it. So we're going to use the matrices that we just wrote, and we want to show the monthly changes in healthcare payments from this year to next year. So we're going to take these two matrices again, and these tell you how much it costs for the entire year. This isn't your monthly plan. If you're paying these monthly, then you know that yearly amount becomes a lot better. So if I want to find the monthly amount, I need to divide all of those numbers by 12, which is the same thing as multiplying by 1/12. And if I want to see the changes from next year, or from this year to next year, what I'm going to do is I need to take matrix B, our matrix from this year, or from next year, and I'm going to subtract my prices this year. That way I can see whether it's going to increase or decrease. So, now what we have to do is we'll copy down matrix B and matrix A and set that up. And I'm going to take a quick commercial break to copy this down, cut this video a little shorter so you guys don't have to just sit and watch me copy down things that we already have. So I would go ahead, pause the video, because when I come back, these matrices will be filled in. All right, welcome back from our brief commercial break there. I figured you guys would enjoy a shorter video and not just watching me copy down two matrices that we already have. So, copy down A and B. So B is on the left, A is on the right. They're the same matrices that we were just working with in this problem here. So copy those down. And now we could distribute. I think it's probably going to be a little easier if we subtract inside the parentheses first. But if you want to distribute this 1/12 through everything, you're more than welcome to. When you subtract these, we're going to take our 683.91 minus 694.32, and that is going to give us negative 1041. 41, not 40. And again, just working, I'm going to work down my first column. 463.10 minus 451.80 is going to give me 1130. And down in the bottom left, you should get 979. And in the right-hand column, top right, I'm going to get negative 25.88. I got that from subtracting my 1699.48. Subtract 1725.36 from that. Take 1217.45 minus 1187.76, and that's going to give us 29.69. And I subtract the bottom right in these two matrices, and I'm going to get 24.96. And now I just multiply each of these by 1/12. If you want to put this into your calculator, it's just easy enough to divide each entry by 12. That's the same thing as multiplying by 1/12. So I end up with, on the left-hand column, negative 1041 divided by 12 is going to give me negative 0.87. I just rounded to 2 decimal places because we're working with money. 1130 divided by 12 is going to give me 0.94. And 0.82 is going to round out that column. Go over to the next column, 2588. Negative 2588 divided by 12 is going to leave me with negative 216. 2969 divided by 12 is going to give me 248. And rounding out that column, divide 2496 by 12, I'm going to get 208. So, what you can see is everything except for the first row is going to increase. So, that means everybody's prices are going to go up. For the individual, it's going to go up 80-90 cents a month. The family is going to go up $2, $2.50. But for the comprehensive coverage, that first row, that's actually going to decrease in price. They're going to pay a little less. Really not bad increases if you have to have increases for your health insurance. Okay, that's all I've got for you today. We'll work on this in class some more, and I will see you guys next time. Thank you.